How do I go through this, and how do I uh, read an article like this and get the information I need? So the first sentence you see here is something like, okay, the most exciting thing you can probably do on Earth is to get away from it. Okay, so right off the bat here, that sounds like it's like a nice introduction that seems very fun. And talking about 13th century China. Shout out to my Chinese people. Okay, I was hoping that. Okay, never mind. Okay, it's really awkward. Uh, uh, okay, what'd you say? Okay, you know what? I get it. I get it. Just give me like uh huh. It's like it's the thought that counts. Oh gosh, jeez. Okay, I'm trying. I'm trying. Okay, I'm hurt. I'm almost hurt there. Okay, okay. Um, so um, so I'm reading through this part here, and it's like a nice introduction, but it's probably not the most helpful for us if we're trying to figure out how do rockets work. This first paragraph here, not exactly the most helpful paragraph for us. The next one here, it says what exactly is space. So we're trying to figure out what rockets are. How do rockets work? So a paragraph that says something about what is exactly a space is also probably not the most helpful paragraph for us. I mean, it's interesting. It's definitely interesting. You can learn a lot from it. But if you're looking at an article and you're like, I need to figure out what I need to know, this is a very like a good way of just ruling out what do you need to know and what do you not need to know. So um, where the next part right here, where does space start? Um, Again, it's pretty interesting. I like knowing where space starts, but if you're trying to once again, if you're trying to figure out how rockets work, this is probably not the most useful paragraph. What is space like? Again, cool. Not exactly the most useful information. Um, what about this next one? Is there more one kind of space? Again, not super useful here. Um, Oh, how do rockets work? Oh, that sounds like it could be really interesting. That sounds like it'd be really useful. If I'm trying to create an explanation of how rockets work, I may or may not want to read a paragraph that says, how do rockets work? So this is where we are going to, so this is definitely this is going to be a very important section here. We want to figure out how rockets work. So it's going to be good to read a section that says, how do rockets work? So this paragraph here is going to be, it's a lot of good information for us. So we're going to read this paragraph here. We're going to try to figure, and from this paragraph, we're going to try to create an additional explanation for how rockets work. And we're also going to take a look at this paragraph about forces. This forces here gives us an idea of the physical mechanism, the physics behind how rockets work. This one is more about a little bit more technical. So I'm going to read through this. Some people have talked about drag and thrust. Yeah, this is the paragraph for you right here. Thrust and drag. Yes, so thrust and drag are huge physics concepts really into rockets and especially in planes. So this will also be a good paragraph to read as well if you want to. The rest of this, it gets pretty technical, escape velocity, parts of a space rocket. So this part is not the most, because we're looking for a big picture idea of how rockets work. So when we get into the really specific and technical parts, it's not as useful. So you can definitely skip this part. But as you can tell here, I just pretty much just went through the article and I just figured out what do I need to know. And honestly, it's these 3 or 4 paragraphs for here. These are probably the most important things to do. So what I'm going to do is I'm going to put you in your groups. I'm going to give you guys a chance to read through these paragraphs here, and I want you to see if you can add to your explanation for how rockets work. So hopefully you can add a little bit of physicsy knowledge, a little bit of the forces, use the little bit of knowledge of forces behind things, and see if you can add to your explanation about rockets and see if you can come up with a more concrete one after this. So I'm going to put you in your groups now, and then what I'm going to do is I am going to give you, let's see, how much time do we need? We'll take maybe 10 minutes or so to read through these. Um, and I think I messed up my breakout rooms. Um, Give me 1 second. I think I messed up the breakout rooms. Okay, there we go. Okay. Um, so yeah, so go through your article and see if you can pick up some stuff from the, see if you can add some information to your um, analysis. There is a plug right there, I think. Like I said, there's a power strip down there, I think. Hi.
How you doing?
How's it going, Stephen? Well, I'm about to put us into a group, and we're about to see if they can read the article and see if they can add something to their explanation of how rockets work. Yeah. So thank you all for discussing about what and creating some, reading the articles and discussing some things about um, how rockets work and getting some more specific explanations. What I want to do is I just sort of want to give you a very quick summary on sort of what I took away from discussions and stuff and what I learned. Basically, with rockets, it's basically rockets like cars. You have fuels. These fuels are reacting together, and then when they're reacting together, they're creating a lot of gases, which produces a lot of pressure. And what happens is when rockets they release pressure in the exhaust gas in the nozzle, and when you release a lot of when you're releasing all of this gas, it's basically producing a force that's coming out. And then when you're ejecting a lot of gas going down and you produce some force going down, it also produces an equal force going up. So basically by throwing something backwards, essentially, you are moving yourself forward. And that's basically how a rocket works. And I know there was one group that I was talking to earlier that was sort of wondering how rockets can work in space. So this is something that I was talking about in the article a little bit, if you got to that part. But the way planes and stuff work on Earth is you literally are pushing against air or you're pushing against the ground. So you sort of need something to push against. In space, there's nothing to push against. So the only way you can get something to go in space is you literally have to throw something backwards, and that in itself will make you go forwards. So if you ever watch like an astronaut movie, right? If you see an astronaut like in a space chair and they're like launching something, the astronaut himself is going to or herself is going to go backwards as well. And that's literally the concept of an equal and opposite reaction. And that's the main principle behind how rockets work. Basically, by throwing something backwards, you can make yourself go forwards. Now, the challenge about rockets, though, is that there's a huge challenge about rockets that relates a lot to fuel efficiency. So in order to sort of better understand this idea of fuel efficiency, what we're first going to do is we're going to look at the fuel efficiency of cars, because that's a more understandable context. So if you or your parents or whatever have ever gone look or saw an ad on TV or looking for cars or whatever, it'll say something like this car gets an EPA estimated 40 miles per gallon, yada, yada, yada. Something like that, where the car manufacturer is flexing about how much miles per gallon they can get. However, what they don't tell you is that these fuel efficiencies are often really inaccurate because the car manufacturers will test the fuel efficiency with no passengers and many of the seats taken out of the car. So basically, imagine like an empty car that they're testing, and they're like, okay, we measured this car had a fuel efficiency of 40 miles a gallon, which seems a little bit misleading. So what I want you to do is I want you to go in your groups here and I want you to just try to discuss why does testing a car with no passengers and no seats, how will that affect the fuel efficiency of a car? Why would that affect the fuel efficiency of a car? And see if you can come up with some key ideas that tells you something about why the lack of passengers and the lack of seats and the lack of stuff, why would that affect the fuel efficiency of your car? So I'm going to put you in your groups again, and then let's see what explanation we can come up with. Yeah. How do rockets move in space? Without orbits? What do you mean without orbits? Uh-huh. So a lot of times you put yourself in an orbit. You basically you slingshot yourself around it. So you basically use the orbit to build a lot of speed, and then you have to use a little bit of fuel to escape that orbit to go straight up. So if you want to escape the orbit, you have to apply fuel essentially to break yourself out of the orbit. Okay, so I heard some really good ideas here. I think the main idea that I just heard from the group I was in was that basically the lighter an object is, the lighter an object is, the lighter an object is, the more fuel efficient it is. The heavier an object is, the less fuel efficient it is. And if we sort of visualize this with a metaphor, right? Imagine you're walking to school with 10 textbooks in your backpack because you're trying to return it. Last day of school, you're trying to dump these backpacks off, these textbooks off. You're walking and it's super heavy, you're using a lot of energy to walk the same distance. As soon as you drop off your textbooks, you are like sprinting out because it's just so easy to run without textbooks in your backpack, right? And in many ways, that's exactly the same as a car. The car, for you, in a car, you are the textbooks and you are just really heavy and you're just really clunky. And so the car doesn't want to carry you. But if the car doesn't have any of you, then the car is going to be able to move really quickly, really easily. And so in many ways, it doesn't have to use as much fuel. So that's a general idea with cars. Now let's talk a little bit about more. Let's try to see if we can relate this to rockets a little bit. But once again, we're going to be talking about cars here. So I want you to imagine that you are making a road trip from your home here to New York. So you're trying to make the trip in one go, so no stops at gas stations. You're not stopping anywhere. So you're not stopping at gas stations, you're not stopping at hotels, motels, whatever. One trip, nonstop, no layovers. So you need to load your car with enough fuel to get from here to New York. So I want you to use the idea of fuel efficiency and the mass of a car. And I want you to figure out what issue do you run into as you continue adding more fuel to your car. So think about the fuel efficiency of a car. How does that relate to the mass? And as you continue fueling your car for the trip, what issue do you run into as you continue adding more fuel? So this is a very important idea in the context of rockets. So I want you to see if you can identify what the idea is. So put you in your breakout rooms. So I like what I heard about this idea of fuel efficiency. So the main idea that I think a lot of people were sort of resonating on was this idea that when you're trying to make this long one-way trip, right, you need a lot of fuel. When you need a lot of fuel, it means you have to fuel up your car, your rocket, right? So when as you're fueling it up, it gets heavier, it gets more massive, the weight increases. When the weight increases, guess what happens to the car or the rocket? The fuel efficiency gets a lot worse. You need a lot more fuel. So what do you have to do? You have to add more fuel. What happens if you add more fuel? The fuel efficiency gets worse. So what do you have to do? You have to add more fuel. What happens if that? Your fuel efficiency gets worse. Okay, so just this vicious cycle where you're adding more fuel, fuel efficiency gets worse, adding more fuel. And so this just eventually it just becomes a huge issue, right? And so because of this, right, the main thing that most, the NASA and other space agencies have to consider when they're building rockets is literally the weight, right? Because if the weight of stuff becomes too heavy, it starts this vicious cycle with fuel. And so you really want to be keeping your weight to a minimum because that sort of makes this challenge a lot easier to deal with. So because of this, right, there's a whole branch of science called material science that's literally used in creating new materials that are more lightweight. Another thing they also consider is the astronauts themselves have to also be on a very strict weight plan because every pound that astronauts carry on the rocket is an additional pound that engineers have to account for in the fueling, right? So because of that, it's actually very important to really maintain a good diet because your weight is a huge concern for space. For space travel, because it's really every pound you carry, you basically need extra fuel to carry that, which means you need extra fuel to carry that. They can get very crazy very quickly. So weight is a huge one. Is also in terms of weight and fuel efficiency. That's another issue with sending stuff to Mars. We won't quite talk about landing on Mars just because of timing, but there is one other topic that I do want to brush up on a little bit about, and that's basically lag. So what is lag? So stop lagging. So if you've ever heard of the term lag, right? I'm sure you've heard it or you used it at some point in your life. You know how infuriating it is, right? So my phone is lagging, my computer is lagging, right? My TV is lagging, right? So what lag is the delay between the action, the stuff that you're trying to do, and then the reaction. So basically, I'm doing something, and then something happens, right? So that's basically what happens here. So it's imagine if I'm talking and you see my mouth moving, and then the audio comes 2 seconds later, right? If you've ever gone on a YouTube video where it's really low quality, right? So I've lost too many games because of lag. I've been there. So if you ever watch a very low quality video on YouTube where it's they're talking and then the audio's out of sync, right? That's super annoying. And you can notice it even if it's half a second, right? And if it's a video game, you can notice that you notice your lag as well, right? So what does the word lag actually mean? So what lag means is the delay between the action and the reaction, right? So for example, in video games, when we measure lag, we use the word ping. And this is something that you also use in computing, not just video games. But video games is probably the main way you heard of the word ping before. And it's basically, it's measuring the delay between your input and then the character doing the action. So let's say that I'm playing a game and I see, oh, look, there's some gold on the floor, right? I want to go pick up the gold. So if my ping in the game was 36 milliseconds, what that means is that if I click the button in my mouse to say pick up the gold, it takes 36 milliseconds between me clicking the button and my character actually picking up the gold, right? So I click the button, 36 milliseconds later, my character picks up the gold, right? And that the measure of that delay is called ping, and that's a measure essentially of lag, right? So 36 milliseconds is a pretty low ping. It's not a lot of time. It's very small, right? But anything over 100 milliseconds can get very noticeable, right? What is this ping? This delay is literally a measurement of how long it takes for the speed of light to travel that distance and back, right? And this is because all communications are done by sending light waves to and from locations. So when I click my mouse, right? If I'm playing a game or something, right? And I'm what happens is I'm clicking my mouse. It sends a signal, a light wave to the server, The server processes that, and then it sends a light wave back to my computer that confirms that I indeed did that action, right? And so if I'm lagging a lot in a game, well, that means that delay. So either the server is really far away, so it takes a lot of time to send a light wave from my computer to the server, or it just means there's a lot of like interference in the way, right? So ideally you want to minimize the amount of lag you have so that things are more responsive. So so that's like usually when you're connecting to a server, right? In terms of websites or whatever, you want to keep the things in the same country, right? So if you're in the US, you want to be operating the US servers. If you're in Europe, you want to be operating a EU server, right? Because if you're connecting from here to Australia, which is something that a lot of gamers have to do, there's a huge issue there. So if you think it's bad connecting from Earth to US to Australia, what happens if you're trying to connect to Mars? Now we will do this math on Tuesday, but the amount of delay it takes from Earth to Mars is much more than 36 milliseconds. Like I think people wish that the delay is 36 milliseconds because it's much larger than that. I think how long it takes from light to go from here to Mars is something that is actually kind of ridiculous. And so we will look at this on Tuesday because we don't quite have time for that today. So what I'm going to do is I think we're going to wrap up here just because of timing. So in terms of homework, you don't have any homework. You don't have any homework. Nothing's new being signed. We will finish this graphic organizer on Tuesday because we didn't quite finish everything today. The one assignment that I mentioned earlier, the position and velocity graphs, the last graph on it, which is the blue velocity graph with a lot of numbers on it, you can skip that one because we didn't quite cover that one in class. So you can definitely skip that one. And I already deleted it from the assignment. So if you want to double check, cross-reference your assignment with the one with the master copy, right, you'll see that I deleted it. So you definitely skip that question. And that should be it pretty much otherwise. Otherwise than that, you're free to go and I'll see you all on Tuesday.
Thank you.
All right, thank you, bye-bye.
Thank you.
See ya.
Thanks, Mr. Hu.